Hello class, we're going to be showing you 5-6, transforming rational parent function with Seth Meyer and Chase Miller. So we'll start out on question 1, which is the parent function 1 over x, and your first step is to try and find your vertical asymptote and your horizontal. We'll start with vertical. Your vertical is found under with the x, as seen on question number 2, the x plus 2. But question 1 does not have a vertical asymptote, so simply x is 0. Your horizontal asymptote is your number next outside of your 1 over x, like in number 2, the negative 3. But the first question does not have one, so it is y equals 0. Next, we'll be looking at if it is positive or negative. You find that out by looking at the 1 above your over x, and if it is a positive, it's positive equation. Negative with the 1, it's a negative equation. So this one is positive, so it'll be a positive. Next is your graphing of your asymptotes, and to graph you look at your vertical and horizontal asymptote. Both are 0, so graphing it will be 0, 0 right there, and then drawing your lines straighter than that, and your asymptotes come down in your first and third quadrant, just outside of your lines that you make with your intersection. Both are equal, both are your positive and negative asymptotes. Lastly, we'll be looking at the domain and range of your equation, always starting with negative infinity for both. And then you look at your vertical and horizontal asymptotes. For domain, it'll be vertical, so you have 0, union to 0, and from 0 to infinity. Same thing with your range, only you use the horizontal asymptote, 0, union from 0 to infinity. And lastly, looking down here at the transformation, you're going to go left 2, and your left or right, it'll be left or right, affects your vertical asymptote, and up and down affects your horizontal. So if you write your parent function 1 over x, and you have no horizontal asymptote, you would go left 2, but if you go left with the x, it would switch, so it would actually be plus 2 to go left 2. And if you want to go down 4, you don't have to switch it, but it'll be on the outside of your equation with a minus 4. So you go down 4 and you go left 2.
Next, we will start with question number 2. We'll start with our vertical asymptote. You look at the bottom of your equation, take the opposite, so x plus 2, it's really x minus 2. So x equals negative 2. And then you look at your horizontal, which is y equals negative 3, because you look right here on the outside of your equation, and you do not take the opposite of that. Next, we'll do our domain and range. Always start with negative infinity for both your domain and range. For domain, you'll look at your vertical asymptote, which is negative 2, x equals negative 2. So put negative 2, union negative 2, comma infinity. Next, you will do your range. Always start at negative infinity. Look at your horizontal asymptote, which is negative 3. Union, negative 3, infinity. Next, we will look if this function is positive or negative. In this case, as you can see, the 1 is positive, and you always look at the 1 over the x. So all you do is just write positive. Next, we will graph. When you graph, you will look for your vertical and horizontal asymptotes. In this case, your vertical will be looking from the bottom and take the opposite. So your vertical will be negative 2, x equals negative 2. So draw a line. Draw a line starting at negative 2. Then look at your horizontal asymptote, which in this case is y equals negative 3. So draw your next line at negative 3. Then, since it's a positive function, your asymptotes will be in quadrants 1 and 3, which both are positive, because when your x goes positive, your y is going positive at the same time. 2 positives equals positive. When your y is going down and your x is going down, 2 negatives times each other equal a positive. Next, we will do our transformation of this asymptote function. So left 3, which is you start with writing what your function was originally, which is y equals 1 over x plus 2. Minus 3. Then you transform it. So left 3, now it will be y equals 1 over x plus 5, since you always take the opposite, and then up 6. So add 6 to negative 3, which will equal positive 3. This next problem is now negative. It is a negative function because now there is a negative next to the 1 that is over x. And so now the asymptotes will be in quadrants 2 and 4 instead of 1 and 3, which both equal negative. So we're going to start with the vertical asymptote, take the opposite of the bottom. It is negative 3, so x equals negative 3. And then we will move on to our horizontal asymptote, y equals 2, because you look at the number outside the equation and you do not take the opposite of it. Next, we'll do our domain and range of this function. Always start with negative infinity. Go to your vertical asymptote for domain, which is negative 3. Union, negative 3, comma infinity. Next, we will do our range. That is according to your horizontal asymptote. So it's positive 2. Start with negative infinity and go to positive 2, union 2, positive infinity.
Positive. positive.
Next, we will check if this function is positive or negative. That is according to the 1 over the x, and in this case, the 1 has a negative sign next to it. So this function now is negative. Next, we will graph. You look right here at your vertical and horizontal asymptotes. So x equals -3. And y equals +2. Now, since this is a negative function, your asymptotes will be in 2 and 4 rather than 1 and 3. So you draw them like this. And the reasons they are in quadrants 2 and 4 is because when x goes negative, y goes up. A negative times a positive is a negative. When x is positive in the fourth quadrant, y goes down. Positive times negative equals negative. Next, we will do our transformation of this function. The original function is y equals -1 over x plus 3 plus 2. Now, and then after you shift it, ignore that, this is from a separate problem. After you shift it, after you reflect it, move it right 3 and up 5. Reflect. Right 3 up 5. So when you reflect this function, the negative automatically cancels out, which makes your new graph in the quadrants 1 and 3 instead of 2 and 4. So it'll be y equals +1 over so it would be 1 over you subtract -3 from this, because right 3 is actually the opposite, which means it's left 3. So it'll just be 1 over x now. And then up 5, you add 5 to the 2, which is your horizontal asymptote. So it'll be +7. And this will be your new transformed function.
So this is the end of the video, and we'd like to thank you for watching. We hope that this helped you in transforming rational parent function problems and graphing them to finding if they're positive or negative, finding the domain and range of your functions, and your vertical and horizontal asymptotes. Also transforming them to find new functions. Once again, thank you for watching. This video is by Chase Miller, Seth Meyer. Thank you.